From the Netherlands, this is the Green Planet Monitor, voices and stories from a warm, wet planet. Today, the geology of cities. They're built out of stuff mined from the ground. That's where all cities will end up, broken down and fossilized.
Some of the materials around us, some of the buildings, like the subway systems, for example, have a high probability of being fossilized. They tunnel through rock.
Some human-made molecules will never break down. Forever chemicals, they're called, and they're everywhere. In non-stick cookware, cosmetics, clothing. They last forever, and they're toxic.
And just imagine, 70% of a human body is water. And we're putting something in called forever chemicals. It's a disgrace.
On a happier note, the human microbiome, all those bacteria living on us and in us, delivering crucial services. Nothing more amazing than the bacteria in the gut of a pregnant woman, steering healthy fetal development.
This I found fascinating. And how could this be? I even had to change my pregnancy lectures to account for the fact that now we have a brand new mechanistic signaling pathway that could participate in physiological changes over the course of pregnancy. But the black box is we don't know how this is happening.
This is the Green Planet Monitor. I'm David Kattenberg. Remember the closing scene from Planet of the Apes, the first one? American astronaut George Taylor, played by Charlton Heston, and a female human buddy trotting horseback down a lonely beach. Suddenly, an awful sight. Something very familiar poking out of the sand. The Statue of Liberty. This isn't a far-off planet. This is planet Earth, Taylor's home, long since destroyed by nuclear war. Its proud structures now fossilized. Without a doubt, that's how all of Earth's great cities will end up millions of years from now, nuclear war or not. Mark Williams is a paleontologist at the University of Leicester in the UK. He studies the geology of cities and their propensity to be fossilized. Cities have a geology, like getting back to this idea of cities having a geology, right? They consist of materials that have a physical and chemical composition that closely matches what's present out there in the rocks of Central Park or in the ground. What geologists dig up, we actually see as part of the urban infrastructure. Can you talk about this?
Yes, and that's, so that's a really
geological and chemical composition.
Absolutely, and that leaves a very interesting signal geologically. So, if you think about a modern city, we're sitting in a relatively modern city now. We're sitting in a classic kind of post-World War II building. And this building is made from things that we typically would associate with cities in that post-World War II era. So it's made of glass, it's made of steel, it's made of concrete, it's made of plastic. And actually the building we're sitting in, if we look across, outside, well, we could be sitting in Holland, yes. We could be sitting in Tokyo. We could be sitting in New York. The buildings look the same. They're very, very similar in terms of their architecture, and they're very, very similar in terms of the materials that they're made of. And those materials, of course, are accumulating in the geological record. So the plastic, the concrete, it's the steel. It potentially will leave a very distinctive geological signal.
But back up a bit, these materials, steel, concrete, plastic, particle board, fiberglass, on and on and on, cladding, they're all composed of materials that are mined.
Absolutely.
And have their analogs. Same materials are found in rock. I mean, can you talk about this aside from the garbage that's going to be left on the surface of the Earth, buried?
Yeah, absolutely. That's part of the accelerating process of our ability to actually extract materials from the broader Earth system, and because these materials are often traded and moved around the planet as well. So, as well as the kind of, if
you look at these one by one, like for example, plastic. What is plastic? Where does it come from? What's concrete? Where does it come from? What are these minerals? What are these geological substances?
Yeah. So obviously plastic is fabricated from hydrocarbons. Oil is the primary chemical source of materials that we use to make plastics. If we're talking about concrete, then we're thinking about limestone, mudstones, sandstones that we'd have to go out and quarry and mix together to make those materials.
Glass.
Glass, yeah. I mean, glass is effectively melted sand. Yes, it's melted quartz. Steel is obviously iron ore, which we extract from various key places around the world,
Fiber board, particle board.
Yeah, I'm not sure what some of those are made of sometimes, David, actually. I mean, they used to be made from materials that were not so good for humans, but absolutely. I mean, I'm not an expert on minerals, so it's difficult for me to talk about all of those different aspects and their sources, but certainly that has also been an accelerating component of the mid to late 20th century. What's more interesting, I think, is the fact that cities have been evolving on this planet for hundreds, thousands of years, and they evolved with their own distinctive geologies, their own distinctive architecture. So, if we were an alien life form and we landed on this planet in the early 20th century, and we landed in England, or we landed in Holland, or North America, or somewhere in Africa or somewhere in Southeast Asia, we would see a very distinctive city made from materials that had largely been sourced locally and which had their own distinctive architectural style. We'd say this is a building which is typical of a city in Southeast Asia, like Hanoi or Saigon, Ho Chi Minh City, or typical of a city in Europe, like London. And so cities had a distinctive biogeography. You knew you were in Southeast Asia immediately because you could tell from the architecture of the buildings. And that's left an archaeological record, a very clear archaeological record of the evolution of culture in Southeast Asia or in Europe or North America. But if you land on this planet now as an alien species, and you land in London or New York or Hanoi or Beijing or wherever, what would you see? You'd see the same. You'd actually be quite confused about, there isn't a biogeography. All the buildings effectively look very, very similar, and they're made from very similar things. And that means that there will be a distinctive geological signature of that, an archaeological signature too. But if we came back 10 million years hence, we'd be able to see, this evolution of a clear cultural architectural identity in Southeast Asia and a clear cultural architectural identity in different regions of Europe and other parts of the world. And then bang, you go into the middle of the 20th century and everything starts to homogenize because materials are being mined on a colossal scale. Those materials are being moved around the world and they're being used to make these gigantic structures, the cities we live in. And that's going to leave a permanent geological record everywhere on the planet. We talked about tunneling under cities, yes, earlier. And, so one thing you'd associate with those large cities are the subways, the underground systems beneath them. They're burrowing actually into the rock. They're permanent structures. They will leave a geological record of us millions of years into the future. And it will be a record for anyone who can read it that will say, wow, my God, there's a sudden capacity for humans to have a major engineering impact on the planet.
But I mean, 1,000, let's say 1,000 or even perhaps 10,000 years from now, fast forward, you'd be, and some alien would come down, or whoever, some future human, robotic archaeologist would do archaeology. They'd find the remains of the degraded remains of buildings that they could still identify as buildings. But 100 million years from now, what would you find?
So I think
all of this stuff would have decomposed, degraded back to the primary minerals. No, what would you see? Would you still see a distinct layer?
Yeah, I think you would. I mean, I agree with you. Obviously, over time, many components of what we built would be decay and would be returned back to the Earth system. But some aspects of it would survive. So plastics, plastics would survive. They'll survive over very long time frames. There are analogues for plastics in nature. There are complex materials in plants, cellulose materials that last millions, hundreds of millions of years. And I think plastic will have the same kind of signature, and it will leave a distinctive chemical and probably fossil signature of this time. Some of the materials around us, some of the buildings, like the subway systems, for example, have a high probability of being fossilized. They tunnel through rock. They're permanent. And just like, sitting here, I'm surrounded by fossils. Fossil horse's tooth from 3 million years ago, fossil snail shell from 2 million years ago. Those burrow systems beneath cities have the possibility to become the fossils of the future, just as many of the buildings and constructions do around us. I mean, it's possible that part of this building we're sitting in could become fossilized. So the original materials might change. The original materials of that fossil shell have changed, but it's recognizably a fossil snail. And I think there'll be a recognizable signal of our cities long into the future. Even if the primary materials start to change, they'll fossilize. They'll preserve a part of this building, or they'll preserve a part of the underground drainage systems in cities, which are so profound underneath all cities. Yes, so it will be there for a very long time, I think.
And a city has a huge mass, and it's pressing down on the lithosphere.
Yes.
And of course, there are a lot of cities. I think most cities in the world are located along the subsiding coastlines. Tell me about this. I mean, what are the prospects for a city like New York City, for example, that's sitting there? What's going to happen?
Yeah. So those cities that are close by the sea, or may be associated with large river basins, where there may be subsidence ongoing, or where the city itself may be actually causing subsidence because of its sheer mass, they have a very high potential to be fossilized. So a city like Shanghai, for example, which is definitely sinking because of water extraction and because of the geology of where it's built, or a city like Jakarta in Indonesia, again, is subsiding and is subject to the ingress of the sea. They have a very high probability of being preserved long into the future and leaving a geological record. Now that's counter perhaps to a city in the centre of a continent, or a city at altitude, where we'd expect the rock cycle, just as it does with mountains, to erode down that landscape over time, and for that sediment then to be transported to the sea. So New York has a good chance of being preserved. London has a good chance of being preserved.
Buried, subsiding, being.
Yeah, absolutely. Not just because of the subsidence of the weight of the city, or as a result of groundwater extraction or of other processes, but also because sea level is rising. And one of the results of the Anthropocene and of all of the carbon dioxide that's been put into the atmosphere is that the oceans are expanding because of thermal expansion, because they're warming, but they're also rising because of the melting of various ice sheets, the West Antarctic, for example, and parts of Greenland ice sheet. So that means that a city like London, which is not far above sea level, a city like New York, a city like Shanghai, could potentially be inundated by water in the coming couple of centuries.
And have you seen projections for what the eastern seaboard of the United States, for example, will look like? I've been wanting to actually go on the internet and see if I can find, projected coastlines in 2200 or 2300.
Yeah, so obviously, the amount of sea level will be linked to which of the various scenarios, the Intergovernmental Panel on Climate Change, which one we follow. If we follow the net zero route, and we're able to reduce the amount of carbon dioxide in the atmosphere, then hopefully sea level rise will not be so great. It might just be in the range of a couple of meters, but that's still significant, because many cities are very low lying. If we carry on with a trajectory where we put more and more carbon dioxide into the atmosphere, then some of the long-term projections might suggest several meters of sea level rise.
But people are talking about 50 or 100 meters of sea level rise potentially if the East Antarctic ice sheet slips into the ocean.
Yeah.
I mean, worst case scenarios, if Earth warms, if we do indeed hurtle into Will Steffen's hothouse Earth.
Yeah.
And as hot as it's been in 50 million years, and sea levels rise, Manhattan Island, Manhattan will be completely deluged.
Yeah.
It'll be underwater.
Yeah. I mean, in the future...
Those skyscrapers will be sticking out of the water.
Yes. I mean, long into the future, this will happen, yes. I mean, those low-lying areas will be inundated.
They will be?
Long into the future. I mean, that's inevitable long into the future because sea level changes over time. And sometimes the Earth is in an ice house state, as it is at present, and sometimes it's in a greenhouse state. When it's in a greenhouse state, there are no polar ice sheets, so sea level is generally higher. In terms of where the projections are going over the next couple of centuries, that really depends on what we do as a species. If we're able to curtail our carbon dioxide emissions and keep them stable and then start to reduce the amount in the atmosphere, then sea level will only rise a relatively small amount. But if we accelerate the amount of CO2 going into the atmosphere over the coming centuries, and yes, I mean, Will Stephen's, and others' idea of a hothouse world is a possibility, and that would result in significantly higher sea levels, and places like London and Manhattan Island and Shanghai and many other low-lying cities will really struggle. But, many low-lying cities are already struggling. I mean, Ho Chi Minh City, the Mekong Delta, there's already sea level rise. Jakarta, sea level rise already having an impact, potentially, on the city. So we're already there, and we already need to start thinking about how we can try to mitigate that. But yeah, low-lying cities have a very high potential of fossilization. There will be fossil cities in the future. And
you've seen the first Planet of the Apes with Charlton Heston?
Yes.
Where at the very end of the movie he realizes the Planet of the Apes is really Earth because he's come across the...
Yes, Statue of Liberty on the beach, yes. Yeah, I mean, it's
God damn them all to hell.
God damn them all to hell. That's it. He beats his hands on the sands, yes. I mean, it's an incredibly evocative image, and it's I mean, yeah, we don't want to get there, yes. We don't want to be in that situation. Long into the future, sea level will change, whether humans are implicated in that or not, because that's what happens with the natural cycles. But over a short time frame, if we don't curtail our CO2 emissions to the atmosphere, sea level will rise very dramatically. So you asked about the eastern seaboard of the USA, and a really good place to look is to think about the climate 3 million years ago when it was last at similar kind of atmospheric CO2 levels to present. And there's been some great work done by a Pliocene research group. United States Geological Survey was a real leader in this.
This was 3 million years ago?
So 3 million years ago, the Pliocene is the last time we think that atmospheric CO2 levels were at this level. Now,
just before the Pleistocene.
Just before the Pleistocene. Now, the world was different.
Just before the ice ages.
Just before the more severe ice age of the northern hemisphere, because the southern hemisphere has been glaciated for 34 million years. But the Pliocene is often used as a good potential scenario for where we might be in the mid to late 21st century, because its atmospheric CO2 levels were similar. It's not a direct analogue because it's got its own inherited climate state, but there's a really nice escarpment that runs down the eastern seaboard of the United States. It's called the Orangeburg Scarp. And it runs through, I think, North Carolina and Virginia, and you can clearly see it on Landsat images. I can send you a picture if you're interested. And it's where sea level was 3 million years ago. It's the old escarpment. It's quite a long way inland, and you can still drive over it. I'm sure people are driving up and down the Orangeburg Scarp every single day and not realising that's the ancient shoreline when sea level was higher because atmospheric CO2 was higher in the atmosphere. So we know as geologists, when there's more CO2 in the atmosphere, the climate's warmer, sea level is higher. And that's where we have to try to, we have to try and slow down the amount of CO2 going into the atmosphere. Otherwise, cities, those visible markers of the Anthropocene, will sink and they will become the fossils of the future.
Mark Williams is a professor at the School of Geography, Geology and the Environment at the University of Leicester in the UK. I'll post links to Williams's research at greenplanetmonitor.net. Their precise scientific name is a mouthful. Per- and polyfluoroalkyl substances, PFASs for short, but you don't want them in your mouth. Hard to avoid. Forever Chemicals are in adhesive tape, non-stick cookware, greasy food wrap, microwave popcorn bags, lipstick. They don't break down, they build up in your body, and they're very bad for your health. And most people have them in their blood. Here's a bad news story.
So, we're here now just to fill up a couple of buckets with earth, and then we proceed to Chemours. Okay?
It's a Saturday morning routine here in the Dutch town of Sliedrecht, a few kilometers upstream from Dordrecht on the Merwede River, an arm of the Rhine. Local politician and activist Joop Keesmaat hops in his car for a 5-minute drive. On a quiet residential street, Joop stops beside a large pile of dark soil. He gets out, pulls a half-dozen buckets and a shovel from the trunk, and starts shoveling. This soil is almost certainly laced with one of those toxic forever chemicals, PFASs they're called. On the other side of the river from Joop's dirt pile, Chemours Dordrecht and its predecessor DuPont have been releasing PFASs for years into their wastewater stream and the atmosphere. DuPont had been using one particularly toxic variety. In 2012, that got replaced by another compound called Genex. At that point, DuPont was licensed to emit 8,000 kilos of the stuff per year. Chemours took over the plant in 2015 and began cutting back on emissions from a base level of about 3,000 kilos per year. So lots of PFAS has gone up Chemours' stack. And this is, you think this is contaminated soil, contaminated with PFAS?
For sure. Chemours is in the southwest there, and the wind is blowing from the southwest. Yeah, so it's, wherever you take the earth here in this area, it's for sure contaminated or polluted by PFAS. Yeah, no doubt about it.
Indeed, soil samples downwind from Chemours Dordrecht have been tested by a Dutch environmental firm and a University of Amsterdam chemistry lab. PFAS concentrations range from 30 to 70 micrograms per kilo, 10 times the regulated Dutch limit. Houses can't be built on these soils. PFASs linger there forever.
So all the carbon atoms, or most of the carbon atoms in those substances, are linked to fluorine atoms. So it is something completely unnatural, also extremely difficult to break down.
Jean-Luc Vitor knows all about forever chemicals. He's a chemist with the European Environmental Bureau, a Brussels-based NGO that wants PFASs banned completely. Their precise scientific name is a mouthful, per- and polyfluoroalkyl substances, but they're not something you want to eat. It's hard not to. Forever chemicals are everywhere, in adhesives, non-stick fry pans, greasy food wrappers, microwave popcorn bags. It smells good. Even lipstick. They don't break down, they accumulate, and they're toxic. And people have them in their blood.
Young people, old people have them. During pregnancy, the baby even ends up with more PFASs, higher concentrations than the mother.
So they cross the placenta and they accumulate in the fetus.
Yes.
They're also in breast milk and inhibit children's immune systems. Based on this finding, the European Food Safety Authority has set tolerable weekly intake of PFASs to 4.4 billionths of a gram per kilo of body weight. This past summer, Germany's Federal Institute for Risk Assessment reported that 50% of Germans exceed that, and a quarter of German women have elevated PFAS levels in their blood. So would about 10% of German babies.
We always say it's like an experiment on a worldwide scale, sort of laboratory where you try out things, you make these chemicals, and after 20 years, hey, everybody's got it in his blood. Oh, we shouldn't have made it.
Jacob de Boer is an analytical chemist at the Free University of Amsterdam. He's analyzed soil samples downwind from the Chemours Dordrecht plant and is familiar with PFAS reports across Europe.
So we know a bit what people have in their blood, and on average, I believe it's around 3 to 3.5 microgram per liter. So it's quite something already. If the safety limit is 7, and we are at 3.5, all of us, everybody in Europe, then it's only a factor 2 below normally that should be factor 10 or more, or even more. But I mean, we are already coming up to the critical level.
Some Europeans are well above the critical level. In the Belgian town of Zwijndrecht, 800 people living within 3 kilometers of a 3M plant had their blood tested. 60% exceeded safe PFAS levels, some by 100-fold. In the wake of this and other horror stories across Europe and the US, the European Union is considering a ban on all fluorinated toxics, about 6,000 compounds in total. PFAS producers like Chemours Dordrecht oppose a blanket ban. Mark Reimers is the Environmental Health, Safety and Sustainability Manager at Chemours' Dordrecht plant.
First of all, I think it's an unprecedented scope which is being embarked in EU. We believe that as a society and also as corporations and governments, we should look at the details and should apply science to regulate appropriately. We know that there can be exceptions. We believe that our materials we are producing, you mentioned Teflon, and Viton is another product we are making. They are used in a lot of products in society. Our position is let's get the facts on the table and make sure that we have the good debates.
While opposing a blanket ban, Chemours has undertaken an effort to reduce its PFAS emissions by 99%. It's also working on non-toxic alternatives to Genex in the manufacturing of Teflon.
We take our responsibility to drive our emissions down to zero as close as possible as a responsible manufacturer. And parallel, of course, we are also looking at non-fluorinated alternatives where possible.
For Joop Keesmaat, standing in front of Chemours' Dordrecht plant, zero emissions can't come soon enough.
Here in front of the gate now, and what we normally do is we dump the earth in a short line in front of the gate as a symbolic protest every week.
Joop and a dozen other activists dump their pails of soil in front of Chemours' gate. One man sprinkles the soil with water that he says is contaminated.
And just imagine, 70% of the human body is water. And we're putting something in called forever chemicals. It's a disgrace.
Another protest complete, Joop drives home. Along the way, he pulls onto a street where he used to live, lined by homes plagued by cancer. Joop thinks PFASs are to blame. Still, he doesn't want Chemours to close. 1,000 people work there. He just wants the company to cut PFAS emissions to zero.
Slowly things are improving, but there is still PFAS emission and still not zero, and that's why we continue our weekly protests against that factory and bringing it under the attention of to the attention of people. That's in fact, but that's what happens.
A recent report reveals that PFASs are present in high concentrations all across Europe. Read more about forever chemicals at greenplanetmonitor.net. You are listening to the Green Planet Monitor. I'm David Kattenberg. the astonishing things that take place inside a healthy human body, none are more astonishing than pregnancy. Women's bodies undergo enormous change in the course of 9 months of pregnancy, all aimed at promoting fetal growth and development. Even more astonishing, bacteria in a pregnant woman's gut help steer the process. Deb Sloboda studies the role a woman's gut microbiome plays in healthy pregnancy. Sloboda is a professor in the Department of Biochemistry and Biomedical Sciences and an associate member of the Departments of Obstetrics, Gynecology, and Pediatrics at McMaster University in Hamilton, Ontario. Can you talk about all the summarize the physiologic changes that a woman goes through, those huge changes, and how those changes in a woman's physiology in the course of 9 months of pregnancy affect the microbiome, the gut microbiome, and how the gut microbiome, it's not just a one-way street, how the gut microbiome modulates those changes in a woman's physiology.
Yeah, thanks for that, David. The changes that a pregnant individual undergoes over the course of becoming pregnant are, as you say, quite vast. And they are amazing. Pretty much every single organ in a pregnant person's body changes. And these are all entirely normal changes. And I would say that most of them are directed to the fact that there is a growing organism and, in fact, another organ entirely, the placenta, which needs energy. And that energy has to be preferentially diverted from the maternal system to the fetal placental system. And so a lot of these changes, including changes in the glucose and insulin signaling patterns and metabolism, immune changes, changes in the obvious hormonal profile. There are changes in blood volume and blood pressure to ensure that there's adequate blood flow going to the uterus to facilitate this nutrient transfer, oxygen, and waste removal. There are changes in the ligament structure to create relaxed joints in the pelvis to ensure that we can actually deliver a very big-headed child, which is new in our species, or relatively new evolutionarily. So all of these things prepare for maximum growth and development to ensure survival post-birth and to ensure safe labor and delivery. So up until, about 2013, so less than 10 years ago, if you asked a fetal physiologist or a perinatal physiologist, how do these changes occur? The number one answer is always, well, it's pregnancy hormones. There are hormones that we know about, estrogen and progesterone, that circulate, considered female sex hormones. But there are other hormones like placental lactogen, like prolactin, that all participate in changes in these organ systems. And that was textbook. That's exactly what I taught in my lectures. But about 10 years ago is when the notion that the microbiome and the gut itself could participate in these changes, that's when it happened. And quite frankly, we don't know much. It is an incredibly exciting area of research. It's brand new. I'm excited to be part of it because I've never been part of such a shift in scientific thought. In 2013, it came about because there was this seminal paper that was published by a group from Germany, and Ruth Ley published a paper showing that where they took the microbiome from otherwise completely normal pregnant individuals from first trimester and third trimester, and they took the stool from these pregnant individuals and they colonized germ-free mice. And germ-free mice are special mice that are raised without microbes. And scientists use these mice to understand what microbes do to the physiology of these whole body organisms, if you will. So what they did was they took these germ-free mice, they colonized them with first trimester and third trimester stool samples from pregnant women. And they saw that the mice that were colonized with first trimester stool looked pretty normal, didn't change their physiology all that much. But when they colonized the mice with third trimester stool, they saw that the mice gained weight, they gained adipose tissue, and they became relatively insulin resistant. This was truly mind-blowing. It actually showed on a more causal pathway that microbes actually participate in the processes that I've just described. And I have a principal interest in glucose and insulin metabolism and adiposity over the course of pregnancy. And so this I found fascinating. And how could this be? I even had to change my pregnancy lectures to account for the fact that now we have a brand new mechanistic signaling pathway that could participate in physiological changes over the course of pregnancy. But the black box is we don't know how this is happening. And other than really, correlational data and the observation that there are shifts in the types and abundances of bacteria that we find in stool samples in humans over the course of pregnancy, we really don't know much about the relationship between the pregnant individual and her gut bacteria and the impacts on her physiology, at least in humans. So what we've been doing in mouse models is trying to understand these relationships and some of the things that could be driving these changes. And we have new exciting data in the lab that was collected by Dr. Tatiana Ribeiro, who showed that the simple act of just becoming pregnant completely changed gut function in female mice. And she showed that pregnancy alters not just the gut bacteria, but gut barrier function. Normally, under normal circumstances, our gut and indeed all of the membranes that are exposed to the external environment have a barrier. We do not want external foreign bodies from entering our blood circulation. That is what the barrier is there for. The barrier is often made up of mucus and very tight opposing cells that prevent the passage of foreign bodies and indeed pathogen, so harmful bacteria from entering and passing through these cells. And in terms of the gut, you can imagine it's not just about harmful bacteria, but we eat all sorts of things, molecules that shouldn't be passing into our circulation. But we see that just by being pregnant, at least if you're a mouse in this case, just by being pregnant, the gut becomes more permeable. And it becomes quite a bit more permeable right at a time point in mid-gestation of these mice. So it actually allows and permits things from the lumen or the outside, the environment, to pass through the maternal gut and into the bloodstream, which is totally fascinating and completely weird.
And is the idea that it's the gut microbiome, it's those bacteria in the gut that are mediating this drop in the mucosal barrier?
Yeah. So yeah, we know from non-pregnant work that bacteria and bacterial components, so pieces of the cell membrane like lipopolysaccharide, can bind to receptors on the epithelial cells of the gut and change certain proteins, tight junction proteins that adhere the cells together. And so these types, both gut bacteria and the metabolites that they produce, they participate in both maintaining and changing that gut barrier. So we are right now in the process of trying to understand how how the bacteria and their metabolites can change the barrier and barrier function. They also can change even mucus. And in fact, Akkermansia municiphala is a bacteria that degrades mucus. So there are certain bacteria that participate in both maintaining and degrading that barrier. We actually right now, at least during pregnancy, don't really know which one of those bacteria are participating in that process. We have some idea, or at least some hypotheses, that if bacteria themselves are not participating, meaning that the lipopolysaccharide isn't participating in the process, we think probably that it's their metabolites, so short chain fatty acids, which are the products of fiber fermentation in our gut. We know that these short chain fatty acids have a really, really important role to play in insulin secretion. There are certain cells in the gut called L cells that have short chain fatty acid receptors, and short chain fatty acids can actually stimulate these gut cells to produce a really important hormone that actually travels to the pancreas to stimulate the production and the secretion of insulin. So it seems logical that this pathway could be participating in some of the metabolic changes that we see over pregnancy, but we actually don't know anything about this over the course of pregnancy. In fact, we don't even have a lot of data on the circulating levels of this hormone. The hormone's called glucagon-like peptide 1. We know very, very little of it about pregnancy at all, even though it's got this massive role to play in pancreatic changes. And I'll just say that there are very significant pancreatic changes that we already know about that occur over the course of pregnancy, like beta cell expansion. Beta cells produce insulin because the pregnant individual becomes naturally more and more insulin resistant over the course of pregnancy, to raise blood glucose so that blood glucose can be transmitted to the fetus preferentially. More and more insulin also has to be produced to counteract this raising glucose. And so where does the insulin come from? Well, it comes from an expansion of the cells in the pancreas that produce this hormone. And we used to think it was all related to progesterone and placental lactogen, all of it. And that's exactly what I used to teach, except now we're thinking about some other things that actually might be eliciting this change. And we've not really thought about the role of the gut before.
And so you're thinking the gut microbiome does, those bacteria must play a role.
Yeah, I think they must play a role. We as I said, we don't know for sure, but I think the role is likely indirect. I don't think that there's gut bacteria circulating around and getting to our pancreas, but I certainly think that gut bacteria, through quite a few, steps beforehand, can certainly be playing a role through production of metabolites. These metabolites are signaling molecules. We know that. We know that they play a really big role in signaling a number of different really important pathways. One of them is metabolism. The other super important one is immune function, and maternal immune remodeling over the course of pregnancy is absolute key during pregnancy, because you don't want to reject a foreign body, which is the fetus, right? The embryo is a foreign body, so immune cell remodeling is also really important. And in other studies, we're looking at how the gut microbiome might participate in that immune remodeling as well.
Deb Sloboda is a professor in the Department of Biochemistry and Biomedical Sciences and an associate member of the Departments of Obstetrics, Gynecology, and Pediatrics at McMaster University in Hamilton, Ontario. That's it for today's GPM, coming to you from Earth Chronicle Productions, Breda in the Netherlands. Listen, read, and watch more Earth stories at greenplanetmonitor.net. And please subscribe. A pop-up box will be popping up real soon. I'm David Kattenberg. Over and out for now.